lovelies, in this video we're going to be ordering fractions. Now this may seem like an easy, simple topic, but it is an area that people underestimate and fall down on so often. It is definitely something that is worth practicing. Now this is the sort of thing that will come up early on in the paper, but it's an easy place where people lose marks because they don't take the questions seriously enough. So it's definitely something that's worth practicing. In this video, we're going to be taking you through 15 different examples at 3 different levels, and you can go through this video as quickly or as slowly as you need to.
When ordering fractions, what we need to do is make sure that the denominators, the bottom numbers, are all the same so that the fractions are easy to compare. Now in question 1, we have a 7 as the denominator of every single fraction. These are going to be really easy to compare to each other. All we have to do is write them in order of how small or big the numerator is. So we're going to go from smallest to biggest. The smallest number here is the 1. I'm just going to cross this out so I don't use it twice. So we have 1/7. We have a second 1/7. We have a 3/7. And we have a 4/7. So you can see that all the numerators are getting bigger as you go towards the right. Now it's important to cross them off as you go so you don't miss any off, and I have missed out 4/7. And even though I already have that, we do need to write it down twice if it's in the list twice. So there's our first set of answers. So looking at question 2, the first thing we need to do is check that denominators are all the same. And they are all 6, so we can compare these fractions. We'll write them in order of how large the numerator is. So the smallest would be the 2/6. Then we have another set of 2/6. We have a 3/6. And another 3/6. And then we have a 4/6. So see that the numerators, the top numbers of the fractions, are getting bigger as you go towards the right. Now for question 3, now we can see that most of these do have an 1/8 as the denominator, but one of the numbers doesn't, 1/4, and we are not going to be able to compare these fractions unless the denominators are the same. So how can we turn that 4 into an 8? Well, we can multiply the entire fraction by 2. So 1 times 2 is 2, and 4 times 2 is 8. So 1/4 is the same fraction as 2/8. Now we can compare. So we're going to look at the numerators now. The smallest numerator is the 2/8 that we just looked at, but I'm not going to write down 2/8. I'm going to write down 1/4. So always write down the original number, not your working out. So after the 2 and 2/8, the next smallest is 4/8. Then we have the 5/8, the 6/8, and the 7/8. You see, as we go to the right, the numerators are getting larger, except that first numerator is not a 1, it's a 2/8 because we converted it. Moving on to question 4, the same thing. Let's check the denominators first. Now you can see that most of these have 9s in, but 2 of them have a 3. It's going to be easier to multiply those up to get 9s than to divide the 9s down to get 3s. So let's turn those into being out of 9. So 2/3, let's multiply the 3 by 3 to get 9. 2 times 3 is 6, and 3 times 3 is 9. And then the 1/3, we'll do the same thing. We'll times the 3 by 3 to get 9. So 1 times 3 is 3, and 3 times 3 is 9. Just remembering to multiply the numerator and the denominator. Do multiply both numbers. Now, when looking for the smallest numerator, that would be the 3 in 3/9. But I'm going to start off by writing a 1/3. Write the original number down. After the 3, the next smallest is the 5/9. After 5/9, the next smallest is the 6/9. We'll write down the original number, which was 2/3. After the 6/9, we have 7/9. And after the 7/9, we have 8/9. So again, the numerators increase as you go towards the right, except for the 2 that we converted. Obviously 2/3, the 2 is smaller than the 5 next to it, but the true value of 2/3 was 6 ninths, so that is larger than the 5. Now, in question 3 and 4, we multiplied the fractions up to get them all have the same denominator. But with question 5, we're going to see it's easier to divide them to get the smaller denominator, the 5. So let's look at how we do that. So the first number is 2/10. If we want that to be out of 5, then we have to divide that by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. The next number is 6/15. We want that to be over 5 instead. So to get to 15 to 5, we're going to divide by 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. And the final number's out of 10. Now, the first number was out of 10, and we divided it by 2. So we'll divide this by 2 as well. So 6 divided by 2 is 3, and 10 divided by 2 is 5. Now, how did I know that this question would be easier dividing than multiplying? Well, it's something that comes with experience. Maybe you try multiplying them up to start with, and maybe multiply the 5s up by 3 to get 15. But then you realise that, well, what can I multiply the 10 by to get 15? It becomes a little bit difficult. So just try a few things, and one way or the other, you're going to get the right answer, but you will find that one way is easier. Just try both if you're not sure. So now they're all out of 5. Let's look for the smallest numerator, and that's the 1/5. So we'll cross out the original number that was and write down 2/10 instead. Then the next smallest is the 2/5. Again, writing down the original fraction, which was 6/15. Then we have a 3/5, which was 6/10. Then we have a 4/5 and a 6/5. And there's our final answer. Now, with the medium questions, you might want to use the method from the easy questions. You might be looking at the denominators and thinking, right, are these factors of each other? Are they multiples? Can I multiply them? Can I divide them? How can I make those denominators the same? But unfortunately, these denominators are so different to each other, it's going to be very difficult to make them all be the same. So we're going to have to use a different method. So you see that what I've done on the right is I've set up every single fraction as a bus stop method division, because fractions and division are the same thing. And I'm going to convert all of these fractions into decimals by doing the bus stop methods. So let's start. So how many 5s go into 4? 0 5s fit into 4, and it'll be remainder 4. Now we've run out of numbers, so we can place down some decimal places. Make sure those are lined up. And we can add on as many zeros as we think we might need, because those zeros have no value. They don't make 4 any bigger to have them there. They do give us space for us to carry a 4 onto. So how many 5s go into 40? 8 exactly, and we've got nothing else to carry. So 4/5 is exactly the same as 0.8. So make a note of that next to the fraction. Now let's do the same thing with 1/7. So how many 7s go into 1? 0, carry the 1, place down some decimal places, and add on as many zeros as we might need. Okay, so how many 7s go into 10? 1, remainder 3. And how many 7s go into 30? So 7 times 4 is 28. From 28 to 30, it would be remainder 2. Now, I have run out of space on the page, but I get the feeling that I'm not going to need every single decimal place. I think going to 2 decimal places will be enough. So I'm just going to write down 0.41, although that number would continue. There'll be more detail there, more decimal places. And if I do need those extra numbers, I can always have a look at that later on. Now, moving on to question 3, we have 1 divided by 3. And I've spotted a mistake here. I've written these in the wrong way around in my bus stop method. So I'll switch those over. And I've left that mistake in on purpose to show you how easy it is to do that. So we're dividing by 3. The 3 has to go on the outside. And we're dividing 1, so the 1 has to go underneath. And I can see I've done the same thing with question 5 as well. So I'll fix that one as well. With the 5th decimal at 7 divided by 12. We're dividing by 12, the 12 goes on the outside, and the 7 goes underneath. So now that's fixed, let's do 1 divided by 3. So how many 3s go into 1? 0, carry the 1, place down decimal places, and as many zeros as we might need. So how many 3's go into 10? That'd be 3 remainder 1. And again, we have how many 3's go into 10? 3 remainder 1. So it looks like that 3 is going to repeat. So when I write down my decimal, it'll be 0.3. And that 3 is recurring. That's going to go on forever. Now let's look at 1 divided by 8. So how many 8's go into 1? 0. Carry the 1. We haven't used the 1 up. Place decimal places. And as many zeros as we might need. So how many 8's go into 10? 1 remainder 2. How many 8's go into 20? That'd be 2 remainder 4. And again, that would continue, but I think we're probably going to be good enough with 2 decimal places. So 0.12. Finally, we're going to do how many 12's go into 7. So that'd be 0. Carry the 7. Place the decimal places. And add on some extra zeros. So how many 12's go into 70? Well, 12 times 5 is 60. Then from 60 up to 70, that would be remainder 10. Then how many 12's go into 100? Well, if 12 times 5 is 60, then 72 would be 6, 84 would be 7, 96 would be 8, and a remainder 4. But again, I think 2 decimal places will be enough, so I'm going to write down 0.58. So now all the fractions have been converted into decimals. We're now going to write them in order. So similar method to before, they've all got 0 units. Look at the tenths, and we have 2 numbers with 1/10. It's 2 numbers in green. So let's look at the hundredths, and the smallest hundredths is 2 hundredths, which belongs to the 1/8. So we'll write 1/8 first. Then 1/7 has 4/10, so that'll be the next smallest. And like with the easy questions, we'll cross them out one number at a time, and I'm going to write down the original number, not my conversion. So I'm going to write fractions here. So I've done 1/10, the next smallest. We have 3/10 with a third, so that will be next. Then we've got a 5/10 with 7/12. And then we've got an 8/10 with 4/5. So those are all our numbers in order by converting them into decimals. Now, moving on to question 2, we're thinking to ourselves, do we really want to do 5 bus stop methods for every single question? Well, the first thing we can do is that we can use shortcuts. We can memorize some of these. So, for example, you might have memorized that 1/4 is 0.25. And so if 1/4 is 0.25, multiply it by 3 for 3/4. 3/25 is 75. So we would have 0.75 for that one. Now, with the others, you might not memorize those, so you would have to do the bus stop methods. Now, in the exam, doing 3 of these or even 5 of these for all of them wouldn't be too big of a deal. It'd be worth the marks. But I don't think there's any benefit doing another 18 of these for all these medium questions. So I'm going to use a calculator for the rest of these. But just keep in mind, if it's a non-calculator paper, you can use a written method to work them out. So for 3/8, I'm going to do 3 divided by 8 on a calculator, and that will give me 0.37. Now that decimal does continue, but for most of these, 2 decimal places will be enough. If you do get 2 repeats, then you can write the number out in more detail if you need it later. Now I'll do 5 divided by 6, which is 0.83. And again, just cutting off the decimal after the first 2 places. And the final one would be 4/9. 4 divided by 9, which is going to give me 0.4 recurring, 0.44. And now we can compare these decimals to each other. So looking at the tenths column, the smallest tenths is a 2. So that would be 1/4. Let's write it down. Then the next smallest tenth is a 3, which was 3/8. The next smallest was a 4 in 4/9. There we have a 7 is the next smallest in 3/4. And then finally 8 is the biggest one in 5/6. So we converted all the fractions into decimals. Use a calculator if you have one, use a bus stop method if you don't, and then look at the tenths to put them in order from smallest to largest. Moving on to question 3. I've converted them all into decimals ahead of time to speed the things up a little bit for us. You should know this method already. And now we're going to put them in order. So we'll look for the smallest tenths, and we have a 0 tenths in a 12th. Then we have 1/10 in a 6th. We have 3/10 in a 3rd. And then we have two numbers that have 4/10. Now in 2/5, the hundredths column would be 0. And in 4/9, because it's recurring, the hundreds column would be a 4. So 2/5 is going to be the smallest one. So if you ever have a tie break, just move on to the next place value. The tenths are the same, look at the hundredths instead. So 4/9 was the largest one there. Now, again, for question 4, I've already prepared the decimal conversions. So let's look at the tenths. So we have 2/10 would be the smallest. Give us 2/8. Then we've got a 3/10. That would give us 5/15. Then we have a 5/10. That would be 2/4. Then we have a 6/10, which would be 4/6. And then finally, we've got our 8/10, which would be 10/12. Again, I use a calculator, which is fairly quick. If you had to do these ones without a calculator, you need to do a bus stop method. Just note that these questions, they can all be simplified first. So you could do 2 divided by 4 in the bus stop method, and you'll get 0.5. But wouldn't it be easier to recognise that you can divide 2/4 by 2 to get a half? Then remember that half is 0.5 and do it that way. So if you can simplify fractions, and you can with question 4 and 5, do that first before you use your bus stop method. Moving on to the last median question, again I've prepped all the decimals, so let's look at the tenths. Now 2 of these are exactly the same, they both have 0.3 recurring. Oh, but before that I do have a 2/10, which would be 2/8, so I'll write that one down first. Then we've got our two 0.3 recurrings. Doesn't really matter which order you write those in, they're both the same number. And 3/9. Then we have a 7/10, 9/12, and we have an 8/10, 12/15. There's our final answer. Moving on to the hard questions now, you'll see that we have a mix of decimals and fractions. Now, these are harder because it tends to be more confusing when you've got decimals and fractions mixed together. But if you use the method I showed you the median questions, you can convert all the fractions into decimals, then this is good news for us because some of them have already been done for us. So actually, the hard questions should be less work for us. Now, I do have 15 different fractions in these 5 questions, and I could do 15 bus stop methods. But again, I'll just give you the decimals for these and use a calculator. And if you've got a calculator, you can do that as well. If you don't, you can do the bus stop method. And if you need more help with the bus stop method, then have a look at the dividing videos. So again, with each fraction, once they're converted into decimals, we're going to look at the tenths first. So in our first question, we have a 2/10 will be the smallest. That would be 2/7. Then we have as our next smallest, we have 2 different numbers with 5/10, but one has 0 numbers in the hundredths column and one has a recurring 3, so that'll be slightly bigger. So we're going to go for the 0.5 first, go write it down as a decimal, and then we have the 0.53. We're going to write that using its original form, which was 8/15. Next biggest tenth was a 6, which was in 2/3. And the final one is a 7, which was in 7/9. So we're just looking at the tenths column, and we're just looking at the numbers raising from left to right as we go through. But we're writing down the original number we're given, if that's a fraction or a decimal, not our conversions, not our working out. Now for question 2, we'll do the same thing. Now we have 2 numbers that have a 1/10. The first one has a 0 in the hundredths column, and the second one has a 6 in the hundredths column. So we'll have the 1/10 first, and then we'll have the 1/6. So if there's a tie break, just look at the next place value along. If the tenths are the same, then look at the hundredths and compare those. Then we've got a 2 in 2/9. Then we have a 6 in 0.6 and a 7 in 0.7. Moving on to question 3, again looking at that tens column. Now we've got 2 of them have got a 2. So looking at the hundredths column, we have a 4 and a 5. So the 4 smaller, 0.24. Then we have a 0.25, which was a quarter. Those numbers are very, very close together, and that's typically done in exams to make you convert them and not have a guess. After the 2's, we have a 3, which was in 4/11. Then we have a 7 as the next smallest, 0.72. And then a 9 is the largest in 11/12. You'll notice for most of these, I'm not even bothered to look at the hundredths column. If the tens column are different, then that's enough to compare. Question 4, we have 3 numbers that have 2/10, so we have to look at the hundredths. If you do find things hard to compare, then you can just add zeros on to make them all the same length. So adding that 0 on to 0.2, now all 3 of them have got 2 digits, they've all got something in the hundredths column, which might make it easier to visualise. And so a 0 will be the smallest, so that's my 3/15. Then 2 hundredths will be the next smallest, and 5 hundredths will be the next smallest. After that, I've got a 4 and an 8 in the tens column, so the 4 next, and then the 8/10. And that's question 4 done. Now, for the final question, every single number looks like it's got an 8 or a 7, but we're very, very careful with the place value here. I'm just going to highlight so I don't get confused. So we have a 0/10 in the first number, 7/10 in the second, 0/10 in the third, 0 in the fourth, and 8 in the fifth. So even though the 0.75 and the 0.074 look quite close to each other, that extra 0 in the tenths position is really, really important, and it means that 0.75 is way bigger than that number. So I'm just going to look at the ones that have 0/10. I'm going to move over to the hundredths column. Now with the hundredths columns, we've got an 8, and another 8, and a 7. So since that 7 is smaller, I can go ahead and write that number down. So 0.074, cross that out. And then we've got 2 numbers that have 8 hundredths. So now we need to look at the thousandths. Now the first one's got 7 thousandths, and the second one, there's nothing written there, which means it's got 0 thousandths. And again, make those numbers the same length if that helps. So 0 thousandths will be the smallest, so we'll write down 0.08, and then 7 thousandths, 0.087. After that, we've got the 7/10, which was 9/12, and we've got the 8/10, which was 12/15. And that's the end of these questions.
Ouch! This is why in some videos I've explained scratches.